If you want to graph a function that already has some different transformations as part of it, my advice would be to first make a table for the function that would be kind of what we would essentially call like the parent function, the one that you would be transforming. So I just think it makes a little bit easier when you're working with this. So here we have the function f of x is 3 to the x power, and g of x is 3 to the x plus 2 power minus 6. So I can see that g of x is the function f of x, but it's just going to shift. And the way that it would shift is left 2 and then down 6. Now, that doesn't mean we have to graph f of x and g of x. It just means let's make a table for f of x, and then we can transform the points on the table to get g of x. So, for instance, if we're going to plug in anything here from, I usually try to do -3, -2, -1, 0, 1, 2, and 3. Not to say that all of these will fit on the graph, but that's usually where I start. So if I plug -3 in here, that's going to be 3 to the -3rd power, or 1 over 3 cubed, which is 1 over 27. 3 to the -2nd power is 1/9. 3 to the -1st is 1/3. 3 to the 0 power is 1. 3 to the 1st power is 3. 3 squared is 9. And 3 cubed is 27. So think about if you had these points over here, and you were going to move them left 2 and then down 6, think about how that's going to impact your table. Going left 2 means that you're going to take a point that, let's say if its x-coordinate was at 1, going left 2 takes 2 away from the x. So really, when we're going left 2, this means that you need to subtract 2 from your x-coordinates. So -3, if I take away 2 from that, it's going to be -5. If I take away 2 from -2, it's going to be -4. -1 minus 2 is -3. 0 minus 2. 1 minus 2. 2 minus 2. And 3 minus 2. Whereas if I take these points and I shift them down 6, that means if you have a point here and you move it down 6, you're taking away 6 from the y coordinate. So down 6 means subtract 6 from your y's. So that means I need to take 1/27 and subtract 6, or in other words, -6 plus 1/27 is going to be -5 and 26/27. If I do 1/9 and I subtract 6, or think of it as -6 plus 1/9, that's going to be -5 and 8/9. 1/3 minus 6 is going to be -5 and 2/3. Then if we do 1 minus 6, that's going to be -5. 3 minus 6 is going to be -3. 9 minus 6 would be 3. And 27 minus 6 would be 21. So now we can just plot these points. So -5, -5, and 26/27 is going to be very, very, very close to an output of -6. -4, -5, and 8/9, again, very close down here. -3, -5, and 2/3 would be about here. -2, -5. -1, -3, 0, 3, and then 1/21 is going to be way off of our graph. But that allows us to create function g of x graphically, basically just from transforming function f of x. Now remember, f of x, we already know a lot about this. We know that the domain is all reals. The range is going to go from 0 to infinity because, right, we picture this as that increasing function here, like that. The y-intercept, if you're going to plug in 0, then that means that you're going to have the point 0, 1, and your asymptote was at y equals 0. So now that we have shifted this 2 to the left and down 6, we know that horizontal asymptote is now down here at y equals -6. There wasn't a reflection, so our graph is still above the horizontal asymptote. So our range is going to go from -6 to infinity now. This did not impact our domain. And then our y-intercept, we have that as part of our table up here. When we plug in 0, we get out 3.